This is 2.2, the second part of the lesson. So if you haven't seen part 1, go back and watch part 1 of 2.2, and this is the second part of it. All right, so we're talking about functions in this section, and we got all the way talking about domain and range and piecewise functions. And so now let's talk about the domain of the function. So the rest of these slides pretty much have to deal with the domain. Domain, remember, is the set of inputs. What is allowed for x's? So typically we have functions that have like y equals x plus 1, and then we start making an xy chart, and we plug in whatever numbers we want, okay? And then I want to know like all of the x's, like what x's am I allowed to plug in? Well, like on this illustration, I could plug in any number. I could plug in 1/2, I could plug in negative 30, I can plug in 17.9, I can plug in any number. I can plug in decimals, fractions, big numbers, small numbers, positive numbers, negative numbers. There are no restrictions. So this would literally be from negative infinity to infinity. Every single number is my domain on that problem. So I want to know what values can I plug in. Well, notice on this first problem, I have 1 over x. Well, notice, you remember one of the rules is you cannot have 0 in the denominator because it's undefined. So here, x cannot be 0. It can be any other number, but it cannot be 0 because you cannot have a 0 on the bottom. So as far as the interval notation, so think of a number line. Here's 0. It can be any number to the left of that. It can also be any number to the right of that, but it cannot be 0. So that's negative infinity all the way to 0, and then 0 all the way to infinity. So it's every single number except for 0. Well, let's look at the next one. Well, here we have x minus 3 on the denominator. Well, again, you cannot have 0 on the denominators, which means x cannot be 3. X cannot be 3. So again, this is on the number line. Think of this as 3. X can be all of the numbers over here and here, but it cannot be 3. So negative infinity to 3, and the union of 3. Now look at the next one. Well, a couple things. Notice x cannot be 0 because you can't have 0 on the bottom. Also, x cannot be negative inside of here, because you can't have a negative square root. It would be an imaginary number, and we're only dealing with what x can be in the real numbers. So here, x has got to be greater than 0. So it's got to be greater than 0. So as long as it's greater than 0, then we're okay. So this is the actual domain. X has to be greater than 0 for this. So we would just simply put 0 all the way to infinity. So no negative numbers would work in that problem. All right, so let's look at some other examples. So here I have the cube root of x. So what can x be? Well, x can actually be anything on a cube root. It could be a negative number, a positive number, because I can take the cube root of something, and it doesn't make a difference if it's positive or negative. So this would be all real numbers, negative infinity to infinity. And then the same thing with the square root. Well, again, the square root has to only be positive, so this would be x is greater or equal to 0. It could be 0, by the way, because it's not in the denominator. I can have the square root of 0. So this would be a bracket at 0 going all the way to infinity. Now look at this next one. You have a polynomial on the bottom, but notice if you factored this, it would be x minus 3 and x minus 2. So here you could see x cannot be 3, x cannot equal 2. If it was 3, or if it was 2, then you would have 0 on the denominator, which you cannot have. So think of a number line. You cannot have 2, you cannot have 3. So it could be any of these numbers, it could be any of these numbers, and it could be any of those numbers. So negative infinity 2 all the way to 3, and then 3 all the way to infinity. And it's the union. Okay, so it cannot be 2 and 3. So here we have the domain of this. So if I said the domain of this, remember, inside of a square root, you can have 0 there, but it cannot be less than 0. It cannot be negative. So basically what we want to do is set this greater or equal to 0 and then solve. So if we solve this, we're going to get negative 3x is greater than negative 4, and then x is less than or equal to 4/3. So as long as x is less than or equal to 4/3, then it will be greater or equal to 0. So as far as the number line, again, here's the 4/3, and less than or equal to is anything over here. So this would be 4/3 to negative infinity. So here you have a function. Notice this is a set of points. So you have domain. If I'm only asking for domain, domain is your set of inputs. Okay, so 0, 3, -9, and 7. So your domain is just literally 4 x's in that value, because that's the only function, points in the function that I'm giving you guys. Now, we've done this as well if reading domain and range. So here I want to know domain and range. So domain is your set of inputs, or the set of x's, and the range is your set of y's, or your outputs. So here, look, domain is look on your x line. So look on your x line, and where is the function going from? So notice it's from here to here on the x line. And then notice they're open circles on both of those, so -5 to -2. Notice the range, which is your y line. So look at the lowest to the highest that it goes, so -4 to +4. And that would be domain and range. Let's go to domain and range of this one. So here we have the domain. Again, domain is your set of x's. So look on your x line, the least to the greatest. So it would be -4 all the way to 3. But notice 3 is a bracket because it has a closed circle. And then you notice the range is the set of y's. So look at your lowest to your highest on your y's. So that's -5, open circle, all the way to 2, closed circle, to be able to do that. And then one last problem, domain and range on this. So we have domain is a set of x's. So the left value, if you notice, this has an arrow, so it keeps going on forever. So this is literally negative infinity all the way to 3 with a bracket. And then notice your range, your lowest to your highest. So the lowest is a -2, and the highest, because of the arrow, it keeps going higher and higher all the way to infinity. That's the second part of 2.2.